Good day. We are Group 3 and today we present our research entitled Assessment of Temperature-Induced Effects on Surveying Instruments, Materials, and Ground Conditions. Temperature changes from daily heat to long-term climate trends can significantly affect surveying accuracy. As explained in previous studies, even small shifts in temperature can influence the performance of instruments, the behavior of materials, and the stability of the ground. These changes may seem minor, but in surveying, even millimeters matter.
Because temperature affects instrument, materials, and ground surfaces all the same time, our study aims to understand how and why these changes occur. Through a literature-based review, we examined more than a decade of scientific findings on thermal expansion, soil thermomechanics, and atmospheric refraction. This is important because surveying is widely used in construction, mapping, engineering design, and land development. Errors caused by heat can affect boundaries, elevations, and structural layout.
Our study used a literature-based and narrative review design. We did not conduct field experiments. Instead, we systematically gathered findings from peer-reviewed articles, technical reports, and international standards published from 1970 to 2025. Sources were obtained from Google Scholar, Science Direct, SpringLink, ResearchGate, and institutional reference such as NOAA or NGS and ISO 11359. We use keywords related to temperature effects on instruments, materials, soils, and atmospheric refraction.
Findings show that steel types expand noticeably under heat, resulting in longer measured values. Fiberglass tapes show much smaller expansion, making them more temperature stable. Digital levels and total station also experience minor drip when exposed to high temperatures.
Different materials respond differently to heat. Aluminum expands fastest. Steel expands moderately but holds heat longer. Rubber and plastic deform and soften significantly. Low expansion alloys such as Invar shows the highest stability. This behavior matters because instrument accuracy depends heavily on materials properties.
Temperature also affects the ground. Clay retains heat the longest, sand heats and cools quickly, loam shows moderate balanced thermal behavior, compacted soil remains the most stable. Even small amounts of soil expansion or contraction can shift reference points used in leveling and geodetic surveys.
Surveyors use several correction practices, like applying tape correction formulas, choosing low expansion materials, shading instruments, allowing instruments to thermally stabilize, and conducting measurements during cooler, stable times of day. These practices help reduce temperature-related errors.
Our results confirm what previous studies have long emphasized. Heat affects surveying instruments through mechanical expansion and electronic drift. It affects material by alternating length, shape, and stiffness. It affects ground surfaces through thermal expansion, moisture loss, and soil displacement. These findings align with established research by Terwin of 2015, Rota, Loria, and Colibri of 2021, and many others, showing that temperature is a dominant source of environmental errors in surveying. This means surveyors must actively monitor temperature and apply proper correction techniques to maintain measurement accuracy.
To conclude, our review clearly shows that temperature has a strong and consistent effect on surveying accuracy. It changes the way instruments calibrate, it affects expansion and contraction of materials, it influences soil stability, and it even alters atmospheric refraction that impacts line of sight measurements. Because of these combined effects, Surveyors must apply proper correction standards, choose materials with low thermal expansion, monitor environmental conditions, and allow instruments to thermally stabilize before use. These practices are essential to maintain accuracy in real world surveying work. We also recognize that this study is limited to existing literature and that temperature interacts with other factors such as humidity, moisture, and wind, areas that future research should explore. Field experiments under Philippine conditions would help quantify these effects more precisely. Overall, our findings highlight one important reminder. Temperature is not just a background condition, it is a critical factor that directly shapes the outcome of every measurement.
We recommend the following. Use low expansion materials for high precision surveys. Avoid conducting measurements during extreme heat. Apply standardized temperature correction formulas consistently. Allow instrument to thermally stabilize before use. Conduct future experimental studies to quantify temperature effects under Philippine conditions. Thank you for being with us throughout this presentation. Our findings highlight a simple truth. Precision in surveying is shaped by the environment, and temperature is one of the factors we cannot afford to ignore. By recognizing its effects, we empower ourselves to produce measurements that are accurate, dependable, and grounded in good scientific practice. We are Group 3, and we remain committed to the advancing precision, integrity, and excellence in the field of surveying. Thank you.